Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College, which is in Schnecksville, Pennsylvania, just outside of Allentown. These videos review key learnings from our science courses here at LTRI-C, and please remember that the Educational Support Services Department does provide walk-in tutoring. This video will review Newton's second law. Second law states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is in the direction of the net force acting on the object. So this is basically a definition of what acceleration is. And the way the second law is stated, it represents this formula over here. Defines the acceleration as the sum of the forces divided by the mass. Now typically when people talk about Newton's second law, they cite F equals ma, which is this form of that equation. So that's the common form that you'll come across most people as they're talking about Newton's second law. But it's actually more of a definition of what acceleration is. Now, it's important to remember that acceleration is a vector quantity. It involves a direction also. And so is force as a vector and the net force, the sum of all the forces, are vector quantities. M, or mass, is the only scalar quantity. Now, when dealing with Newton's second law, typical type of problem is you'll have some body that is being acted upon by a bunch of forces. So almost all body, you say you're going to have a force of gravity, and typically if it's sitting on something that's got a normal force acting up on it, and if somebody is pushing on it over here, F1, and somebody's pulling over here with F2, but then pulling over this way at F3, you would look at that object, you would do a sum of all the forces. So you would sum up all the forces, and you'd get F1 plus F2 plus F3 plus Fg plus Fn. And remember, these are all vector quantities, so they also involve a direction. And if you do a sum of the forces and you end up equal to some resultant force, you do not get to zero. If you were zero, you would be under Newton's first law. But since in this case we said no, we didn't end up at zero, we actually ended up with some type of resultant force. Let's just say it's like that. That's your total of all the forces added together. Now that you have a force, that means it will be acceleration. And that acceleration, that's force, is going to be the mass times that acceleration. And so that's how you would address a second law problem. You would sum all the forces, see if you have a force, a resultant force after you sum them all together. And then if you do, you're under the second law, and you can calculate an acceleration. And remember, because we're dealing with direction here, typically you would have you would set up a XY scale here, and these forces that are off in an angle, let's say our resultant force here, would have a force in the Y direction and a force in the X direction. So you would break it up into X direction and Y direction and do your vector analysis. Now, in summary, the second law relates motion to the cause of that motion. So it's a relationship between acceleration and what causes that acceleration, which would be the net force in a direction. So it's another way to think about this is that net force can be seen as an action capable of accelerating an object. And so when you look at an object, you sum up the forces, you get that net force. And if it's not equal to zero, then it's capable of accelerating that object. And that object could already be having some velocity, as we talked about in Newton's first law video that I did. An object moving at constant velocity is not accelerating. But if you take that constant velocity and now give it a boost with a force and you accelerate it to a higher velocity, or you slow it down to a slower velocity, you would have done that with some net force, and that net force is what was capable of either accelerating or decelerating that object. So it's important to think when we talk Newton's second law, thinking about that net force and that it's capable of doing something, and you're going to sum the forces and see if there is a net force, and that the net force is not equal to zero, which would be under the first law of Newton. Now, just to finally here, the SI unit for force is the Newton, and we normally represent that with a capital N. And the Newton is defined as the force required to accelerate a 1 kilogram mass to 1 meter per second square of acceleration. So 1 Newton equals 1 kilogram meter per second squared. And you often will utilize that when you work problems. Thank you.